Okay. Okay. All right. So today I will be briefing in terms of on the previous topic, chapter number 3. Okay, on the toxicity and toxicology. Right. I have posted the materials, the pre-recorded video on our last class Monday, and I believe you guys have read the slide and you have watched the video. All right. So the purpose of today's lecture is to briefly explain in details on the calculation parts. Okay, with regard to the probability and calculation, with the probability analysis. Okay, all right. So you guys can refer to the slides that I have provided, because I'm going to explain using that slide. So if you have any question or inquiries on that, you just let me know. I can just explain to you on this. All right, it's very important, this topic, because it involves a calculation. This is one of the calculation topic besides others. All right, I think we have like 3 topics that relates to calculation. Okay, all right. Okay, and then for the next hours of tutorials, it will be asynchronous, non face to face. As I mentioned, if we're gonna meet face to face, I will be informing you guys a day earlier. All right. So I will give you the tutorials according to the schedule. So please do the tutorials. Then we will see on next week whether we should meet face to face to discuss on that or not. All right. Okay. All right. I'll just share my screen. Boleh nampak ke?
Boleh doktor.
Okay. So you have the slides and you have the video. So no need for me to explain everything in details on each of it, because you guys have read and heard the video. So what I'm going to explain in details is on the calculation parts, right? So I'm going to move fast on this. You guys can just read it or watch my video on this. Okay. The main thing on this is on the probability calculation. Okay. All right. This is a graph, which is that relationship between a percentage of what? A percentage of the incident to happen, the percentage of damage to happen. All right. So it gives some, it quantify the severity of the accident. Okay, and also a probates. If you can say, this is a probates, meaning a probability, kebarangkalian that damage to happen, atau kebarangkalian kerosakan ataupun kematian ataupun kecederaan berlaku. Okay, so how we can relate between the probability of the accident to happen, which relate to the percentage to quantify how much severe, how bad is the effect of the probability of the accident to happen. All right, so this is the graph. Okay, when you have to, this is the graph that correlates between these two, probabilities and percentage. Okay, in easier way, this is the transformation of the graph. Okay, normally it will be provided table 2.4. Okay, is a transformation from percentage to probability. Actually, it's from this graph. Okay, it's being transformed into this table. Right. So on your left side is the percentage. Okay, for example, we have 10%. Okay, 10, and this is at the top also is the percentage. If, for example, if I want to calculate or to determine what is the percentage, to convert percentage of 21, for example, 21%, how much is the probability? Okay, so you still look at the 20 over here. Hold on, let me put the, okay, see the 20, 21 is over here. So this 1, 20 plus 1. So the value is 4.19. All right. So if the probability that you calculate is 4.19, or you can back calculate, you get the probability. So the probability is here. So meaning that the percentage of it to happen is 21%. If you have like 4.23% of probability, 4.23% probability, the percentage will be 22. Or 5.71, the probability is around 70 plus 6. Sorry, this like, avoiding the 6%. So it's like 76%. So this is how you convert the five from probability in terms of percentage. Okay. To be in details, let's move further in terms of this equation. So this is the equation, the relationship between the percentage and the probates. Okay. So you have like y equals to k1 plus k2 ln v. So what is y? Y is the probability. Okay. Y is the probability. So to calculate the probability, you need to have a constant k1 and k2. Okay, and also ln v. What is v? V is the causative variables. Okay, so to calculate the probates, you need to have this value k1 and k2, and you need to have the variables, causative variables. What causes the probability? Okay, for example, you can see this table. The type of injury, the causative variable, the v, this is v, and this is k1 and k2. For example, you want to calculate the probability of death from lung hemorrhage. Okay, so what is the probability of people suffered death from lung hemorrhage? Okay, so you have y equals to k1 negative 77.1 plus k2 6.91 ln v. What is v? V is the p naught. What is P naught? P naught is the, you see, is the peak of a pressure. Okay, it is an explosion. So when it comes to explosion, the variables is the peak of a pressure, meaning the pressure of the explosion. The higher the pressure, the higher the probability, or the higher the severity right now. So normally, to calculate a probate analysis, a probability from an explosion, for example, here, death from lung hemorrhage, you need to have the value of the pressure. Eardrum ruptures, you need to have the value of a pressure. Death from an impact, you need to have the J. What is J? J is the impulse. It's an impact, right? And same goes to structural damage and glass breakage. Another example, a probability of another accident, which is a toxic release. So toxic release, for example, how much probability of people suffered death from ammonia. So you need to have K1, K2. So the variables is C and T. What is C? C is the concentration of the ammonia. How much is the concentration of the ammonia? And T is this is a big T, right? A big T is the time interval. How long you're being exposed to at a certain concentration of the ammonia. So when you have all these variables, you can calculate the severity of people exposed to the accident. So you have variables, you have various type of injuries or damage over here. Then you can calculate the so-called the percentage. You can quantify them, right? Let's go for example. Write the relationship between percentage and probability for burn death from pool burning. Okay, tengok balik jadual tadi. Burn death from pool burning. So, Y sama dengan negative 14.9 plus K2 2.56 ln V. This is ln, the whole variables here is V, ln V. Okay, and then injuries from the impact explosion. So what is the injuries from the impact explosion? See, injuries from impact explosion. Explosion, where impact. impact. Flying arrangement, injury for impact. Yeah, here. Injury from impact, you have like y equals to negative 39.1 plus 4.45 ln J. Ln J. Right. Setakat ni faham tak? How to develop the equation?
Faham.
Faham doktor.
Faham doktor.
Right. Now, kita pergi example to calculate. Right now. A blast, in an explosion, a blast produces a peak over pressure. Right? It's a P naught of 47,000 Newton per meter square. So this is the P naught. Okay, soalan dia, what fraction of structures will be damaged by exposure to this overpressure? Okay, kita tengok kat sini, structures damage. Fraction of structures will be damaged. So kita tengok balik kat table. Okay, tak apa. Kita baca soalan dulu. Kemudian, what fraction of people exposed will die as result of lung hemorrhage? Meaning die for lung hemorrhage. Kemudian yang ketiga, what fraction will have eardrum ruptures? So kita ada 3 percentage nak kena calculate ni. Pertama, structure damage. Kedua, lung hemorrhage. Kita tengok Q point Tengok dia punya structure damage. Ini is structure damage. Jangan salah tengok dia punya equation. Dia kat table tu. Kemudian this is die as a lung hemorrhage. Right? Kemudian eardrum ruptures. So we have 3 equation kat situ. Okay. So first of all, kita develop dulu the equation. Kemudian last kali, what conclusion about the effect of this blast can be drawn? So daripada ketiga-tiga ni, apa conclusion yang kita boleh buat? Jadi kita tengok. Right. So the probit is here, the general one. So structure damage, back to the table tadi, this is K1, K2, this is ln V. So this is the V, peak over pressure. Death from lung hemorrhage, K1, K2, ln V, this is V. Eardrum ruptures, K1, K2, and ln V. So first, kita develop dulu dia punya equation. So maklumat yang dia bagi, yang ni dah ada. P naught dah ada. So kita masukkan P naught, nilai P naught ni dalam ni tadi. Berapa P naught? P naught is like 47,000. Make sure observe the units. Tengok unit kat sini. Unit kat sini, P naught adalah Newton per meter square. Alright? Jangan terus ambil, letak dalam sistem. Kalau tiba-tiba unit dia lain, bukan Newton per meter square, you need to convert. Because the equation has been developed based on the unit right now. So kalau unit dibagi bukan dalam seperti mana dalam jadual, convert dulu seperti yang dalam jadual, baru masuk dalam equation. Remember that. Banyak student salah buat. Dia tak tengok unit, terus ambil nilai dalam tu, habis. Kalau masuk nilai, ni salah, nilai Y akan salah, kemudian nilai percentage pun akan salah. So hilang markah banyak kat situ. Okay? So make sure observe on that. Right? So dah dapat ni. So P naught 47,000 masuk dalam equation, kita dapat Y sama dengan 7.61 for structure damage. Kemudian lung hemorrhage, Y negative 2.79, eardrum ruptures, Y 5.163. Ini semua adalah kebarangkalian. Okay, probability. This is probability. Okay, probability. Semuanya adalah kebarangkalian of a structure damage 7.6, death negative 2.2, eardrum ruptures 5. So dia soalan dia tanya, what fraction? Meaning that the percentage lah, fraction. You need to quantify them. Sebab kita tak tahu berapa banyak sekarang ni. Ini baru probability, kebarangkalian dia berlaku. Okay, to quantify then you go to the table. Tengok table balik. So tadi ada 7.61. Kita tengok 7.61. 7.61 dekat mana? Sini 7.33 dekat bawah. 7.61 adalah dekat sini. Right, di tengah-tengah antara 7.58 dengan 7.65. So how do we do? Sebab macam mana kita nak buat sebab tak ada dalam jadual kat sini. So kita interpolate. Alright? Tahu interpolate macam mana? Pernah buat tak interpolation?
Pernah.
Buat interpolation. Alright. Nilai 7.58 adalah 99.5. So 99.5 equals to 7.58. Alright. Saya tulis pakai mouse sebab tu tulisan cantik sangat ni. Kemudian kita ada X. Dia adalah 7.62. Yang kita nak 7.62. So 7.65 adalah 99.6. So 99.6 adalah 7.65. So you can calculate the X. So that's how you do right now. Okay. So bila kita dah calculate, sama juga. Kemudian next adalah negatif 2.76. Ada negatif. So dalam jadual ni semuanya positif. Macam mana ni? Okay. So dalam jadual ni semuanya nilai probability adalah positif. Tak ada yang negatif. So kalau you dapat negatif, maksud dia adalah dia punya percentage dia adalah kosong. Okay. So remember that. Kalau probability you dapat negatif, Y tu dapat negatif, dia percentage dia adalah kosong. Jangan susah-susah nak interpolate pula dalam jadual tu. Memang tak ada, confirm tak ada. Right now. Okay. So tadi kita dapat percentage of structural damage lebih kurang 99.6%. Maknanya 99.6% when exposed to that kind of pressure, that much of pressure, that amount of pressure explosion, 99.6% will be structure will be damaged. So kita dah tahu, dah quantify kat situ. Okay. Kemudian daripada eardrum ruptures, berapa ramai ataupun what is the percentage of the people exposed to that kind of explosion suffered eardrum ruptures is around 56%. Half. Okay. Half people will suffer from eardrum ruptures. So this is how you calculate kat situ. So kita dapat ketiga-tiganya sekarang ni. So soalan last kali adalah conclusion ni kan. So this is how you write the conclusion. The blast, the explosion is not serious enough to expect fatalities. Kenapa tak cakap to expect fatalities? Sebab tak ada yang mati pun. Sebab kosong. Tak ada orang mati right now. So that explosion will not cause fatalities. Kita dapat tahu kat sini. Okay. But serious enough to cause extensive damage to the surrounding structures. Macam mana cakap extensive? Sebab 99%, 99.6% structure damage. And to rupture of more than half of the people exposed. Sebab kita dapat kat sini lebih kurang 56%. More than half of people exposed suffered from eardrum ruptures. So this is how you write the conclusion. Jangan buat conclusion by tulis damage is 99.6%, eardrum ruptures 56%. Itu bukan conclusion. Okay, itu jawapannya tadi. Saya nak you buat summary tentang calculation tu tadi. This is how you do the summary. Okay, alright. Ada soalan?
So far okey lagi doktor.
Senang kan? Tak ada soalan
Tak ada doktor.
Okay. So soalan dia kadang-kadang dia tak direct macam ni sahaja tau. Okay. Kadang-kadang kalau ikutkan yang ni direct. Ni soalan direct ni sebenarnya. Okay, sekejap. Ni soalan direct. You calculate Y by ada K1, K2, ln V. Kadang-kadang dia bagi Y. Dia bagi probit ataupun dia bagi percentage. You calculate dia punya Y. Okay. So dia akan modify question tu depending on the situation right now. Okay. So tak semestinya dia akan straight to the point calculate Y saja. Okay. Sebab yang ni dengan ni fix. This value is fixed right now. Alright. And sometimes you need to calculate this. the causative variables. Contohnya, dia bagi tahu the percentage of lung hemorrhage is sekian, 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 sekian. So, what is the peak over pressure that cause that kind of severity? Contoh. Nampak dia boleh putar balik kat situ. Okay? So, itu salah satu contoh yang you guys akan jumpa nanti dalam soalan-soalan tutorial yang saya akan blast kejap lagi dalam Google Classroom nanti. Okay, so you guys akan dapat nanti dalam Google Classroom. Please do the tutorials. Nanti kita akan semak tutorial tu nanti. Okay, alright. Soalan?
Okay, doktor.
Soalan clear
Clear.
Alright. Okay. Alright. So, itu saja yang saya nak explain on the calculation part. So, saya to make sure whether you understand or not, please do the tutorials selepas ni yang saya akan bagi dalam Google Classroom. Okay. If you have any question, just buzz in the Google Classroom. Bubuh je message kat situ. InsyaAllah, will try my best to reply. And then next week insyaAllah kita akan go through jawapan. Kalau semua tak ada masalah, saya just akan bagi jawapan dia lah nanti. Sebab ini straightforward je sebenarnya. So senang. Nanti kita akan bagi another calculation yang melibatkan lagi complex punya calculation in terms of the probit and the percentage of accident to happen. Okay, alright. Kalau tak ada soalan, kita berhenti kat sini. Ada soalan? Going one? Going to?
Tak ada, sir.
Tak ada, sir. Tak ada, doktor.
Tak ada, doktor.
Very clear.
Alright, okay. So, I believe add and drop session pun dah habis. So, you guys kira dah permanent dalam group ni Group L dengan M ni. So, tak ada lagi orang nak add, tak ada lagi nak drop ke apa ke semua tak ada. So, saya akan finalizekan attendance. Nanti saya akan omit mana-mana yang dah drop this group lah ataupun this course. Okay, alright.
Okay, sir.
Alright, okay. Thank you very much, guys. So please wait on the Google Classroom for the tutorials to be blast. Alright, okay, thank you. Assalamualaikum.
Thank you,
Salam.
doktor.
Thank you, doktor.
Thank you, doktor. Waalaikumsalam.
Thank you, doktor.
Thank you, doktor.